Future Vision. Meet Robbie the Robotic Guide Dog. Presented on the 22nd of August 2024 by Dr. Wasim Ahmed and Dr. Ola Popoola from Glasgow University.
Good morning, everybody.
Morning.
As we know, this is the Rainbow Group, which is a group of 5 small local organisations around the country. Just so you know who they are: Support for Sight Essex, Sight Advice South Lakes, which is me, Tim, Sutton Vision, which is Vicky, Outlookers, and Sight Airedale, which is Anthony. He's on screen. Every month we have something called Future Vision, and we look at the tech of the future. We've had some great stuff in the past. Today is no exception. This is one of our, looking at the audience that have come, is our most popular one, I would say, for years. So no pressure, Wasim. And we have Glasgow University. We have the 2 pioneers here, Wasim and Dr. Ola. They are the pioneers of Robbie the Robot Guide Dog. And this is a robot guide. I've seen pictures, I've seen videos. Robbie exists. Okay. So over to you, Wasim, who's going to do the presentation with Dr. Ola as well. Hi, both of you.
Good morning, everyone. It's a pleasure, and thank you very much for the organizer and team inviting us. As we are very, very excited to speak to you guys. And Dr. Ola is here with me. I will use a few slides for myself, but we are quite familiar, and we will go through every detail that we want to discuss, we want to present, and we want to talk about it. So first of all, the intelligent robot, the Robbie, in this case. So my name is Dr. Wasim Ahmed, and I am a co-investigator on this project. I'm a senior lecturer at University of Glasgow. It's called James Watts School of Engineering. The school has been named after a very pioneered scientist, James Watts, who invented so many things for the UK. And we belong to a research group called Autonomous System and Connectivity. Dr. Ola, do you want to quickly say something about yourself, and then I will talk about a little bit about our group, please.
Excellent. Thank you again, and thanks for the invitation to this talk. I am Dr. Ola Popoola. I'm also a lecturer at the James Watts School of Engineering. And I look into robotics and communications in terms of connectivity, and then also in terms of artificial intelligence. In terms of my teaching, I teach dynamics and control, looking at how robots can be stable under different kind of conditions and environments. During the talk, I think I'll get to say a bit more about myself, but I think I would hand over back to you, Dr. Wasim, for now.
Thank you very much, Dr. Ola. So my background is I work in artificial intelligence and robotics. Our group, along with Dr. Ola, we have at least 45 professor researchers who are working on various aspects of telecommunication, wireless communication, robotics, control, and assistive technology. So I will start a little bit of background and the motivation for this project. So we personally have been working in assistive technology for the past 7 to 8 years. And when we say assistive technology, we majorly work in assistive technology for blind and visually impaired people, as well as the technology that could be used for people who cannot speak, the deaf and mute people. We also develop various type of technologies to support elderly and physically challenged people. So in terms of the assistive technology for blind and visually impaired people, in the past, we have developed various technologies that they can wear it as a necklace, they can wear it like a watch, they can attach it with their cane, they can wear it like a belt or such kind of things. So when in 2018, 2019, we were introduced with a local charity, it's called Forth Valley Sensory Center, which is one of our local charity here in Fife. And the RNIB, the Royal National Institute for Blind, their Scotland wing. So that was our second charity. Since then, we have arranged and organized several events at their centers where we showcased our developed technology. We tested some of our gadgets with the end user, and we also ask the end user to involve in terms of the designing process, in terms of what do they want to see, what are the main challenges they face, and according that challenges, we try to come up with various type of technology which can solve these problems. So in 2021, when we just came out of lockdown, we tested one of our developed technology with the Fourth Valley Sensory Center user. We had a brainstorming day there, and I presented a couple of our technologies to them just to see how they to get their feedback, to gauge their feedback, and to get their insight. And there we had the very first conversation about robotics. I presented to them that we use various types of robots for our user interaction with people talking, coming like a customer services, and people asking some of like the if they want to buy something as a ticket or at surgery. And I wanted to see the excitement and if there is any desire. And I was very right that there was a very positive response from the community that they were very excited. Yes, they said, we would love to see robotics coming and helping us. And that was like kind of a start of our journey. So in January, it took us a year or so. In January 2022, after a 1 year of development, we developed our first prototype using a Pepper robot. A Pepper is a humanoid robot. It is like around 5 feet tall. It has 2 arms. It has hands, but only it has 4 fingers instead of 5. It has a head. It does not have a leg because it has a row wheels. It slides on wheels. So this was the robot which can talk, which can interact. It has a tactile sensor on its head.
Which one is a demonstration?
Tactile sensor on its hands. So we trained it. We set up like a small shopping center at one of their hall, and we displayed kind of pretend 3 or 4 shops at the shopping center, including one of the restroom. And we thought if they come, for example, to a shopping center, how they can be assisted by this humanoid robot. If they want to go to X shop, Y shop, or if they want to go to a shop where they want to ask the robot if the thing they want to buy is the right thing. For example, if they want to buy a bottle of water, if they want to buy something, a tin of a tin of food, they want to seek some help from the robot. So this was the initial prototype which we evaluated with 2 groups. And some of these pictures which are on my screen, some of the group picture where all the user from one of the group are there, including one of the guide dog, our end users, and also the Fourth Valley Sensory Center head, and some of the technology experts from RNIB. And there is one picture where one of our participant, she has been working with us for last 2-3 years, and she actually tried out the Pepper robot at that time, as well as the Robbie as well. She has been working with us here in this case. So after completing this very fascinating day and collecting the feedback from the technology experts, from the end user, we had a group, a very vast group, which have a range of spectrum about the blindness. Some of are partially blind. Some of had a restricted vision. Some of them are fully blind, and so on and so forth. So we collected the feedback from them, and we reckon that majority of the people appreciate it and they want to see this development. They said it is very interesting. It could be a very useful, especially indoor spaces where majority of the devices and majority of the navigation doesn't work. So there were three different areas where we made the progress for the first prototype. The first thing was that Pepper can guide the end user or the user safely from obstacles and take them safely from point A to point B. So that's the navigation part. So it can navigate a person safely from point A to point B. If Pepper will see any obstacle, static, or any obstacle which are dynamic, it will try to help the end user. The second thing was it can interact with the end user. You can talk to a robot like we interact with each other. With a restriction, of course, there was a constraint at the time, how much conversation in terms of detail you can engage with this Pepper. And then the third thing was the object detection, object recognition, and describing the object. This was the other aspect. So after doing this evaluation, we continued our development with Pepper, but we found out that there was one major obstacle, and that obstacle was that Pepper cannot cope uneven surfaces because it slides, it has a roller, so it cannot manage or cope the uneven surfaces. So we continued our development and we were finding alternatives, and we come across this robot, which I will from here onward, I will hand over to Dr. Ola. He will try to explain some part of it, and then we'll come back and talk about the other things. Dr. Ola, please. So this was what I explained in terms of the Pepper robot. So this was the thing. Okay, Dr. Ola, please.
Picture of a dog.
Yeah. Hi. So yes. So in front of you we have Robo Guide. It's a robotic dog with features to address or tackle the issues that Dr. Wasim mentioned in his presentation. The key thing here is Robo Guide is to help with assisting navigation of persons with visual impairment. In order to do that, Robo Guide has to see the environment and also has to be able to, in a way, communicate this sight to the persons with visual impairment. So in essence, what we are trying to do is to extend the senses of blind persons. We understand there are lots of technologies around these, and then we've also looked into various kind of solutions. But the key thing is that this particular Robo Guide stands out because it pairs easily with an existing solution, which is the normal guide dogs. People have trained, people have understood how to work with guide dogs, and then transitioning from that to this would be almost a seamless process. Next slide, please. Okay. So for RoboGuide, before we look at its features, one of the things that we looked at with RoboGuide is that it needs to not just see, but also understand spaces. The question we'll ask ourselves is, if a space is new to us as persons, how do we learn to navigate such spaces? And what we would do in most times is that we would go to those spaces, we would not know anywhere around. We would look around, we would use signs and symbols to map those spaces in our heads. And then when we've understood the spaces, sometimes we don't have enough information from signs and symbols. We would ask questions from people around us. And then possibly you go to a new space and you say, okay, where is the kitchen? And then they'll show you, oh, you walk forward and turn right to get to the kitchen and things like that. So that's how we have learned to learn new spaces. However, the key issue here was taking this intuitive behavior of ours and putting that in a robot. For the robot to be able to also learn a new space, and when it learns the new space, then it can easily help the visually impaired person to navigate that space. So in order to do this, we wrote a very simple algorithm that asks from the robot, is this space new? If the space is new, the robot learns a map of the space and stores the map.
1 of 3.
The second step of the algorithm is, if no is the answer to the original question, is this space new, then the robot uses its pre-existing map to navigate that space. There are 5 key features of technologies that we use to implement this solution. The first one was intelligent voice interaction. For RoboGuide to be useful to its users, it has to be able to communicate with its users. There are various technologies we explored for this communication protocol, but then we needed something natural, something intuitive. So unlike using symbols or taps or controllers, which is what you would have in modern day robotics, we decided to take the step further to use voice commands, and then the user can speak or give commands to the robot. Initially, this was a bit challenging because when we are speaking, we have various kind of words that we use in our commands. So we need to create a library for the commands. In order to achieve this library, we decided to go into intelligent conversations via large language models. Large language models helps the robot to have not a static library of words to form its command. It gives the robot a bit of intelligence to be able to interpret a large array or a large number of input words and interpret them to suitable actions. So that block in the center with the conversion with the large language models makes the robot very, very flexible. So you don't have to say, go to point A all the time. You could say, go forward. You could say, take me to this point. You could give various input commands. So the input for the large language model is very, very vast. And then the action set, which is the steps the robots will take to execute the commands given by the person, is limited within the robot. That conversion is what we've used intelligent large language models to implement. The second feature we have is the visual slam. For us, it's very, very easy when we look around and we just see the environment. We're able to perceive things with our millions of years of evolution. We have grown in our perception abilities. We can detect colors, we detect obstacles, we detect objects in the indoor environment. How do we transfer this ability to robots? And that's what we use the visual SLAM for. SLAM stands for simultaneous localization and mapping. In an indoor environment or in an unfamiliar environment, the robot needs to know where it is. And in order for you to know where you are, you also have to know what environment you are located. So the complex problem here was understanding both localization and mapping. If, for instance, you're put in a desert without a map, you don't know where you are, you don't know where you are in the environment, it's almost impossible to describe to anybody to come and pick you up, because unless you have landmarks. If you have no landmark, just a vast desert, You cannot just see them beside the sand. Everywhere is beside the sand. So it becomes a very complex problem. And in order to address that problem, we have to do what we call simultaneous. So the robot, because the robot doesn't know the map and it doesn't know its location. In order to do these things together, we have to implement this new intelligent algorithm that uses visual cues to form a map. When it uses the visual cues to form a map, it also uses the map at the same time to localize itself. And solving that problem will help the robots understand the environment very, very well in such a way that, step one now, when the user gives a command for the robot to navigate that unknown environment, the robot will be able to navigate the area. The third feature that we looked into was to address the question, how should it navigate the area? It's one thing to understand where you are. It's another thing to safely walk or navigate where you are. And this will be a very, very easy analogy for us. Imagine you close your eyes and I say, okay, with your eyes closed, walk around your own house. Now, you know your house, but then we will see us stretching our hands to try to feel or try to detect obstacles around before we move. And that is the third algorithm we implemented in Robbie, navigation and obstacle avoidance. While navigating the indoor space, it also has to detect obstacles and avoid them. The fourth one builds on the third. While trying to avoid obstacles, there is a key problem there. We have two kinds of obstacles. You have the static obstacles and you have the dynamic obstacles. The static obstacles are the obstacles that do not move. They are easy to classify. When you recognize them, the robot will easily form a path that takes it away from the static obstacle. But then there are also the dynamic obstacles. So if the obstacle is dynamic and the robot forms a path that doesn't take it away from the future position of such dynamic obstacles, then there will be collisions. So we also implemented an intelligent object detection algorithm that not only sees the obstacle, but also classifies and helps the robot avoid the obstacle. In addition to the object detection stack, the robot is also equipped to recognize objects. So if, let's say, one of the, when Dr. Wasim was speaking, one of the things he mentioned was that this robot was not just to help the blind navigate obstacles or navigate indoor spaces, but was also designed to help them accomplish some day-to-day tasks. For instance, when you go to the shop and say, okay, I want to buy what? I want to buy oranges. Now the robot, when it has mapped that shop, will be able to take the user to where the oranges are and say, these are oranges. And that is carried out by this visual object detection algorithm. The fifth feature and the final one that we implemented in RoboGuide was the modular design. The modular design was, I wouldn't say it's strictly a technological feature, but I would say it's a more visionary feature. It's futuristic in nature. What you would, with the news out there, you would have understood that the field of robotics is rapidly evolving. And one of the things we are required to do is that we needed to separate our solution from the robot chassis. So the robot chassis itself is what gives the robot the legs, the arms of the robot. That's all. So there are various solutions for the robot chassis, but the modular design of the solution is developed in such a way that when you take that modularity and plug on any robot, that new robot will function exactly as RoboGuide should. Next slide, please. Next slide, Dr. Wasim. So all I've been speaking, this is a very technical illustration of them. I think I'm going to skip this because it's just going to be a bit too much information. But if you need additional clarity on any of the features which we have implemented via this algorithm, you can contact myself or Dr. Wasim, and we're happy to share that with you. Next slide, please.
Yeah, I can explain to the audience what we are looking at. It's this picture represents the eyes and the ears and the brain of the Robbie. So we can see some of the cameras which actually take the picture, understand the environment. There are depth map in there in one of the camera at the top, which understand how far things are. And then on the left-hand side, there's a picture with some circles. We talk about the brain power, because in today's technology, when we want to run the programs and the algorithms, the lot of data that we collect and we need to process it before we can make some decision, we need the computational power. And of course, to run all these things, we need a battery. So you can see the black box, that's the brain, that's the computational power. So that's the onboard computer, you could say, which process all this information, make the decision, and then interact with the user. And then on the left-hand side, there's a blue kind of a pack, which represent a battery pack, which powers all this kind of a small computer in this case. So in once we completed this development, and this journey took us a year and a half, from moving from the Pepper robot, the humanoid robot, to moving to the four-leg dog robot in this case. And during this whole period, we had volunteers from Forth Valley Sensory Center and RNIB who were continuously giving their input. They were engaged, what we call it, during the co-design process. So they were helping us, telling us what is good, what they want to see, what they like it, and what is kind of causing a problem or which is not very good. So after all this development, when we reach up to a level, then we wanted to evaluate, and we selected a couple of venues where we thought we can see the potential or the Robbie in action for the user. So we consider the shopping center, we consider hospital setting, and we consider museum. And after a lot of discussion, we selected to evaluate Robbie's performance and Robbie's in action in a Hunterian museum, which is one of the oldest museum in Scotland, and it's inside University of Glasgow, and it's free for the visitors to come and visit it. So we selected museum for a reason, because it was a very first time when we were planning to run the kind of end user evaluation with the actually user in kind of a real environment, still control. We don't want to see any kind of accident or any kind of other things happening. Secondly, Robbie draws a lot of attention from the crowd and from the audience. So we tried to take it in other venues, and we realized that we won't be able to conduct our experiments or our end user experiments, because we see that dozens of people, or sometimes a lot of crowd, come around Robbie. They want to take pictures, they want to see its functionality, they want to talk. And that's why we thought we need a little bit of isolation where we can conduct our business, evaluate its performance, and then maybe we'll try out. Even though we wanted to carry out these experiments in a shopping center, we ended up carrying out these experiments in a museum setting. So in this case, we had 5 participants. We had fully blind, partially sighted, and visually impaired people. So they carried out They took at least, the experiment was like this. The Robbie was at the reception desk when a person to the come to visit the museum. They will ask if they want to use the Robbie for assistant. If they say yes, then they will be given Robbie, and then they start talking with the Robbie. And for the whole experiment, we selected 5 artifacts where Robbie will ask them if they want to go to each artifacts in a sequence manner, or if they want to skip any one of them. And then they will interact with them. The user will say, yes, let me take me to the first artifacts or name of the artifacts, and then Robbie will walk them to the first artifacts, and then Robbie will talk about very briefly about the artifact or about that piece of art. Will tell them what it is, how does it look like, it kind of metaform and things, and then we'll pose a question. Do you want to know, are you interested, or do you want to know more about the artifacts? And if you say, yes, I am very much keen, it's interesting, I want to know a bit more, then Robbie will provide more information, which we gathered this information, we gathered from the museum. And then if there is more conversation, as Dr. Ola was talking about the potential of large language model, then Robbie is also capable of to fetch the information in real time from the internet and provide further information. If Robbie cannot handle the question and cannot find the information from the pre-fed information, then Robbie can also get the information from online and then provide that information to the user. And then once it's done, it will take them to the next artifacts. So during that period, in this picture, one of the picture what I'm displaying at the screen, we can see there was a large glass case or boxes in the museum. There were some pillars, and Robbie successfully actually navigated not itself, but also safely guided the blind people through all these boxes and edges and all the walls and everything, and completed the whole route and given them the whole tour, and the end of the tour also wish them or say them goodbye. So we repeated that experiment with all the user, and then we gather the evaluation form. We ask their experience. I will not go through the detail, but I can tell you very briefly some of the pros and some of the cons of the or some of the positives and negatives of the feedback which we received it. So one feedback that we received was the walking speed of the robot. It was static. It doesn't change. It doesn't kind of adopt the user footstep. So this was something we gathered it, and we are working on that. So the user can either control the speed of the robot, or robot Robbie can automatically adopt after a little bit of walk. It can automatically judge and adopt the end user walking space. They were very, very positive about the interactivity. They thought it is a very positive thing, because they don't have to rely on kind of only audio recorded thing or only relying people. They can interact and they can fetch the information. In this picture also, that one of the user, they also tell us that the lead they were using, it's a flex, it's not firm. So sometimes they cannot fully actually feel the pull or the navigation. So we also changed that for the guide dog. Like we have replaced it with a proper guide dog lead that normally they use it. So these were some of the feedback we gathered it. We are happy to take any question, any feedback you have it, or any kind of other things, I will hand over to Tim, and Tim
Okay.
can
Thank
conduct
you.
the
Yeah,
business from here. I will
thank,
stop sharing the screen.
Thank you.
thank you. Just what can I just say to people, if you want to unmute, here are the instructions. On a landline phone, press 6. If you're on a laptop, most things are in the bottom left-hand corner. The same applies to iPads and iPhones, but you might have to tap your screen to get the red microphone. So, okay, left-hand corner is the best advice I can give. Okay, folks, so unmute yourselves if you wish, and I shall ask the first couple of questions. Well, thank you both for that. This is quite a huge, remarkable bit of research you've done, to say the least. I've got one question to start on. This is on the slam bit, to Dr. Ola's bit. How quickly can Robbie map? How quickly? I got the impression that he can map as he goes, or does that? Am I wrong in that?
Depending on the size of the indoor space, it's for an original space, it takes about 20 to 30 minutes for the museum for it to map the top floor where we used for the experiment. So depending on the size of the space, depending on the nature of the artifacts, so one interesting bit we faced with the museum case is that the artifacts were encased in glasses. So if you put your camera phone in front of a glass, you would almost see nothing. And then we had to find a way to ensure that the robots would see glass, which is transparent in nature from the perspective of the camera. So roughly it takes 20 to 30 minutes depending on the nature of the space. A much bigger space will take more time. I think that's it. Dr. Wasim, do you want to add to that?
Yeah, I just want to, in a very simple term, I could say, let's say if we have, there are two steps in mapping. The first step is the initial map. For example, if I bring Robbie to one of our end user and they live in a house or a flat, let's say a 1-bedroom, 2-bedroom flat, okay? So map this environment initially, it might take 10, 15 minutes to half an hour. That's the, but then we are talking about changing the setting. For example, suddenly I got a new table and I want to change some of my settings. That's what happens. Robbie has the capability that it does not have to rescan everything. So if there is a small change, Robbie can immediately adopt and tweak its existing map. It can stitch it, it can embed it into its memory, like how we human understand. So for example, if I go to a friend's house and next time when I go and I say, oh, this is a new table, I didn't see this last time. So we know how my friend's dining room, sitting room looks like, and then I can update my memory. So same way, Robbie has this capability that it can map the spaces initially, and then it can update it. And this is all true so far for indoor spaces. So current version of Robbie cannot go outside and map everything, because we are looking at that will be the next stage of it. If you want to take it, Robbie, outside for a walk or outside for any other thing. So at the moment, we are concentrating indoor venues, indoor spaces, and Robbie can do it. If we immediately put Robbie in a scenario where it does not have any initial map, at least it can guide you through the path to take you safely, because there are the obstacle avoidance and navigating you from point A to B is independent of the mapping. Mapping works together when they have it, but without that, it can still help the user to navigate through the obstacles. So that's just to clarify it.
So okay, that sounds good. So my second point would be, not a point. So Robbie could, let's say with Morrison's or Sainsbury's, they could actually employ Robbie, couldn't they? And you could turn up to Sainsbury's, hire Robbie, go around the supermarket, because Robbie knows where everything is. Correct?
Absolutely. So currently, for the last 5-6 months, we have been working with the consultant companies looking at where potential lies outside, like kind of our community, blind and partial sighted community, where no, of course they can have it as a personal use at home, but how about if we want to bring them for other user group, for example, physically challenged group or people who wants to. So one of the use case we are also looking into it, the consultant and business cases, if this can be used at the supermarket, for example, anyone come to visit the supermarket, they can have a Robbie, which is with the integrated trolley and can help them not only to carry their trolley, but also engage with them and also tell them where different things are. And for our blind and partial sighted community, it can also help them to navigate safely. So it can have this kind of capability, and this can be used, what you just said, Tim. Absolutely right.
Excellent. If people who have managed to unmute,
we had a question in the chat from Christine about price. How much one would cost? Is there going to be?
Very, very good question, and I was expecting that from now. In terms of the prototype that we are working on, it's a bit expensive. The business model, we are looking into it. We just had a meeting with our consultants and other things yesterday, and we are looking at the current model that Robbie with the guy, 4 legs dog robot and this kind of thing. We are hoping if we are producing in a large number, we are around a £2,000 kind of a price tag. Robot itself is quite expensive in this case. However, we are also looking at it's a cheaper version where not necessarily you want to have a 4-leg robot. You can have a small kind of a wheel robot, and it can range in terms of price range from £500 to maybe 700 or 500 to £1,000. That will be a cheaper version. So when we roll out, we are working on that, and we are very keen to have that kind of business model. We have this in mind that all the end user will not have in terms of usability, in terms of buying potential or capacity. There will be a diversity. So we want to bring functionality wise, price range, and we will have various models so end user can choose from a range according to their needs, according to their kind of affordability.
Thank you. We have a hands up by Lisa. Lisa, do you want to ask your question?
Yes. Sorry, bear with me a sec. It was 2 questions, really.
That's okay.
What is the lead time on the commercial availability? And with your obstacle avoidance, does it know how big the person is? I.e., if you're 4'8" or 6'3", or if you're a size 8 or a size 20, because obviously avoiding obstacles might not be necessary for shorter, smaller people, but might be more necessary for bigger, taller people.
Can you clarify, Lisa? It means the user instead of what is in front of them. Am I right?
Yes. Does it know that I'm 5'10"?
No, it doesn't know. But the next version will understand from your footstep. So if you are talking about in terms of your walking pace, how fast and how big your footsteps are, we will be having this in 2 different control mechanism. One is it is in the control of the user. They can control how fast or the pace of the robot, how they can set that pace. The other will be adaptive pace. If you walk a bit, it's your Robbie, and if you walk with the Robbie for some time, then it will understand your pace, and it can adopt. It will be very quick to adopt your pace in terms of how slow or how fast you want to walk. But currently, it does not.
So for example, sorry.
I don't know. Sorry, just one sec. I need to mute someone, but I can't find them.
So, sorry, for example, My sight in sunlight, I slow down massively because I lose my sight. When it's a bit darker, I can speed up. Is it that reactive?
It could be. It can be. I mean, there are some features which will be universal feature for everyone, but there could be some features we can tailor it. We can kind of tweak it for individual. For example, how you train the guide dog, it could be in that case could be tweaking. So these are some of the things. If, for example, you have certain wish list, we can see that if that could be tweaking in kind of a thing for you as an end user, but currently not, unfortunately.
Okay. And my second question was the availability. What is the timescale?
So availability wise, if let's say everything goes right, we have the funding and everything, we are hoping like in 2 years' time, it should be available for the end user commercially, that you should buy one of them.
Thank you.
Thank you.
Next one is Martin, who raised his hands.
Oh, thank you. Sorry, wasn't quite ready.
Okay.
I've got a few questions, so I'll be as quick as I can. So obviously you've discussed battery and everything, and that's brilliant. In terms of obviously the mapping capability, which again sounds quite interesting, and whatever technology I choose, be that LiDAR, whatever the case might be, is where is this data being stored? Is it going to be stored and processed on device, or is it something that's going to have to be moved into the cloud, and are we going to have to consider connectivity for any potential users? Also, my other questions relate to the potential rollout of something like this. Is that you may or may not be aware that the competition in this space is actually getting quite interesting now, and a lot of people are looking at wearable technologies now, and certainly like Arc Vision and Biped, and that's wearable technology that provides pretty much all of this information, but through headsets or wearable information. Where do you see yourselves kind of fitting into that market going forward? And also, what is the testing phase in terms of usability of people with sight loss and stuff? And final question, and I appreciate you've mentioned you've worked with RNIB. I used to lead the innovation team at Guide Dogs, and this was something that obviously we were quite keen and looking at in general when I was at Guide Dogs. So we're talking 2017, 2018. But there's some of the reasons why we didn't continue to investigate it were obviously very financially driven and financially motivated and things like that. But some of the other things that came into it was the concept of trust, the concept of people not being able to trust technology over a dog. And I know that's improved massively in the last 8 years or so. So I know that's no longer so much the big draw. And obviously, I appreciate the pros and cons of all of this. And obviously, it sounds really great. And I don't want to, put a dampener on any of it. It sounds amazing. But, the realistic nature of people needing this in their home is very slim. It certainly needs to be more geared towards outdoor spaces, and consider what that training pathway would also look like, and are you linked with the RWPN, which is the Rehab Workers Professional Network too? So I appreciate there's a lot of questions there, so apologies, but yeah, I'm really interested.
Thank you.
Thank you, Martin. I will pick some of the questions in terms of the navigation data. Depending upon the long term, if we take a scenario that we already are thinking, for example, if you go a shopping center and in future they will have 20 of these robots sitting there for the end user, and you can go and get one of you, move around, and then at the checkout point you can hand it over like a disability kind of a wheelchair or scooter. Normally, when you go to a shopping center now, you can get it issued, and then on the way back, you can return it. It will be a very similar kind of a concept. If we think about that concept, then of course, this mapping capability will sit in a cloud, and the information will be real. The Robbie has the Wi-Fi capability. It talks because some of the processing has to be done on the cloud, because it's a energy consumption is quite high if we do everything on the robot in the future. So what will be, there will be map and this kind of some dynamic changes, and that will be connected, and all the 20 robots in that shopping center will know each other, where they are, and share the information and the maps and all things. So they will sit in a cloud. But if you are using an individual personal such kind of robot, non necessary that this kind of information will sit in cloud. This can sit on your local robot. However, still it will be either 5G or Wi-Fi enable to fetch information and talk like kind of a computational power with the cloud. So that's the one thing. The other thing is we are working with several other organizations, including Guide Dog. We had a couple of meetings with them. They are very, very interesting to cooperate with, coordinate with us. We are also keen to learn from them. They see a potential not only for the community, for end user, but they also see this as a potential for rehabilitation and also for the training for their trainers as well. So there is a lot of potential for this technology. You are right that in terms of the size, in terms of that thing, it might not fit or suitable currently for individual home user. But as I said, we will have a smaller version, which will be like a football kind of a size on a wheel, which could be used like it can follow you, or it can go around very easily in your living area or in your kitchen, and it can follow, you can talk. We are aware of it, our competitors, what they are doing, how they are doing, but we think our approach and that thing is different. We want to, yes, there are technology available. There are different technologies available where you can wear it on like a glasses, like headset, or on the wristband, but they have their own limitation. Okay, this could be adoptable in terms of you can wear a small earpiece with it, and you can quietly talk with it, and it can sit somewhere in your room, and you can walk around. You can still get that help. You have that flexibility. You don't have to keep it on your head or on your eyes or your shoulder all the time. So there is a plus and minus in this case. But thank you very much for your feedback.
Cheers. Thank you.
Thank you. Next one is Sharon on the screen, who raised her hand.
Hi there. I think I'm a bit of a gatecrasher here. I happened to see Martin's post about this webinar this morning. I'm quite excited about this. As you can tell from the accent, I'm in Scotland, and I have tried numerous times to get in touch with Glasgow University after seeing your article on the Scottish News, probably April, May time. Really, really excited. I've been a guide dog user for 30 years. Wow. Over COVID period, went for 3 years without a dog, and that was horrendous. And actually, I think my question is, where do you see this in the future? I know you're saying that at the moment it can't be used for outdoor use. Is that the next part you're looking at? What would be the time scale for that? And a dog isn't necessarily the best mobility aid for everybody. And for lots of different reasons, you have to care for the dog. You know, that's sometimes why people do use a white stick, because they can put it in the cupboard, if you know what I mean. Absolutely. So for me, this is so exciting. I would really, really be interested in working with you if you're still looking for volunteers. Absolutely. So my question really is, where do you see this going to be able to, I'm going to use the word replace, if people want their dog, rather than it being a dog, it is a robot. That's really my question. Where do you see that in the future?
Thank you very much, Sharon. This is very encouraging, and you raise a very good point. It's some people have asked, are you trying to replace and the guide dog? And we always tell them, we are not trying to replace it. If people have their guide dog, they are happy. Yes, absolutely fine. But this is also a transition, like a person like you, and we met several other people who actually their either guide dog is getting retired or is retiring, or there's a shortage of supply guide dog, and they are without the guide dog for months, days, or years. And that's where the Robbie can come in and try to help you or rescue you or support you. during that period of time. That's absolutely fine in this case. The second question is in terms of the outdoor. Absolutely, we are looking at once we get the conclusion and we get the next support in terms of funding and development, our next target is looking into getting the feedback for and trying to develop its capability for outdoor mobility, to take it from indoor to outdoor, and make it kind of support and things and running that thing for the outdoor locality. Yes, this is our definitely next target. As soon as if we go ahead and we get the green signal, as soon as early next year, we will start kind of developing, and middle of next year, we'll start doing the trial for that outdoor things. So please take mine and also Dr. Ola detail from Tim, or get in touch via our email, and we will be very happy to have you in our team in terms of the end user and also who the co-design team as well, please.
Okay.
Right.
Tim, can you tell me how I actually get in touch with you? Because I say I followed the link that Martin had shared yesterday, so I'm not really very sure. Or maybe at the end I can stay on the call and and you can give me your email or something. That would be really helpful. Thank you.
Absolutely. So anybody listening now, I'm Tim from Site Advice South Lakes. So if you haven't got a pen, look on the website, Site Advice South Lakes in Cumbria. But the email, you ready for this, Sharon? It's quite a simple one.
I've not got anybody taking it down, so hopefully I'll be able to remember it. But on you go.
It's a really simple one. Tim at Site Advice.
Site Advice.
That's it. Tim at siteadvice.org.uk.
Right. Okay. Site Advice. Okay. Thank you.
Yeah, and anybody interested? I mean, obviously they can get in touch with Vicky, Shuji, Anthony, and the Outlookers, and myself.
But I do appreciate. I have gate crashed being in Scotland, and obviously I just really excited about this. This is I think this is what I've been looking for in life.
Excellent. Okay, I'm going to have to pull this to an end now because we've gone over. Which is brilliant. I mean, I'll just do a quick summary. What I'm obviously you're using the world's greatest technology, large language models, and all that. So we know that's in good. We know the information is going to be great. But I personally, I like the corporate thing of the supermarkets, the museums, maybe airports. I mean, who knows? Where big corporates can just buy this, and that's really great. And then there's the other bit, of course, where as an individual, as Sharon pointed out, maybe you don't want to look after a dog. Maybe you just want something you can put in your cupboard, take it out when you need. And it comes in, it's not just a dog. It could be a football. Who knows what you could put it in? There's all different ways you can put this technology into something. And the dog is a great way of selling it, by the way. That's why people came to this meeting. Robbie, it's a great way of showing off the technologies that you've actually encompassed. But it doesn't have to be a dog, does it? A dog is great, though. We love the idea of a dog. So 100%. Brilliant. I think it's great. We'll invite you back in a year's time as well, if you like.
Please.
Can I just ask one question, my usual question, language-wise? Is the dog only going to be speaking in English, or are you going to have various languages? And obviously I'm from Hungary, and like Siri doesn't really recognize me, and I always have the same issues. So is it going to have various languages?
Absolutely. This is, again, we highlighted this yesterday when we were talking with our consultant company, that this is another thing. When we get visitors coming to museum, to this kind of exhibition, they are not all English speakers. They come from all over the world, and to cater them, it will speak. The Robbie will speak your language.
Excellent. Thank you.
You are welcome.
Thank you so much for the presentation. Lovely to meet you both, and thank you for your time this morning. And this is going to be on YouTube in a couple of days' time. So
thank you. Thank you very much again, Tim. Thank you very much to all the audience who came and listened to us, and also asked the question and feedback. We are on a journey, honestly. It's not, we don't think so. Our mission at the University of Glasgow, and especially our group, is how we can support. And this project is very close to our heart. We are not doing it for the sake of any big tech and kind of earning a big kind of money. We want to roll out to make a difference in people's life. This is our mission. Finger crossed, we succeed.
You will.
We are trying our best to raise funds so we can make it a successful product, and we can bring it to the actual user who will benefit out of it. So thank you very much for having us. Please get in touch if you have any question, any feedback, anything. Either directly, you can search our names on Google from University of Glasgow, Wasim Ahmed or Dr. Ola Popoola, or James Watt School of Engineering Robo Guide. You will get all information, or get in touch with Tim and he will be definitely provide our detail with us. Thank you very much.
Thank you.
Thank you for changing the world.
You.
Well done. And do you want to
Thank
hang on at the end, the pair of you?
Yeah, be here.
Future Vision is a series of technology events aimed at people living with sight loss. Future Vision is a collaborative project between 6 local independent sight societies. Sight Advice South Lakes in Cumbria, My Sight Notts in Nottingham, Sight Airedale in the Airedale area of North and West Yorkshire, Support for Sight in Mid and West Essex, Sutton Vision in the London Borough of Sutton, and Outlookers in Huddersfield, West Yorkshire. Live Well and Future Vision. We hope you enjoyed this presentation. The Live Well events take place on the second Thursday of each month at 10 AM. Future Vision sessions take place on the fourth Thursday of each month at 10 AM and are technology events aimed at people living with sight loss. To attend the next session or to suggest future topics, please contact your local sight society who will be able to provide you with the Zoom link.